Hello, this is Mr. Wyrick. I'm here to talk to you today about Lesson 4.8, the 8th lesson from Chapter 4. And this time we'll be dealing with coordinate proofs of triangles. I've listed under here as cartography. This is really the kind of stuff that you do if you're dealing with a map. So it has a lot to do with being able to work well with Cartesian coordinates, the coordinate plane, and really understanding what that means for your different shapes, in this case for a triangle. Okay, so the first thing that it has listed as something that you need to do is position and label these. So if we understand, for example, that we have a 45, 45, 90 right triangle, we know that it is isosceles, and we know that these are exactly the same. So if this is on the origin of our Cartesian coordinates, it's at 0, 0, then the distance here is going to be A. The distance here is also going to be A. So this point up here is at 0 over A up, and this point out here at this end of the triangle is at A over 0 up, since we know those distances are the same. Okay? Now, if we had another triangle over here, and it's at the same place, but we are told that this one is scalene, we don't need to know the coordinates. This will be our A, this will be our B. We're still dealing with a right triangle. We can say A squared plus B squared equals C squared, and this will be 0A, but this other point will be B, 0. So it's knowing where those labels would go if it were a number, and being able to fill those in appropriately. When it comes to missing coordinates, their example, I think, really kind of tells you something about what's going on. If we have, again, our Cartesian coordinates here, we have our origin, and we have this triangle that overlaps the origin. So up here, we don't know this distance, but we could call this A0. So if we are given that this one back here is a negative, or sorry, this is the y-intercept, it would be 0A. Okay, so that one's 0A. This over here could be a negative 2b, comma 0. If we are given that these two are congruent, then we know we're going to go the exact same distance on the other side of the origin. So this is going to be 2b, comma 0. More of what you're going to do with these first two, positioning and labeling and finding missing coordinates, is going to be it's abstract. It's not numbers. So it's more about logic. It's more about understanding why something is the way it is than actually having to deal with numbers, divide anything out, anything like that. When we do a coordinate proof, their example is something like this. And they've got this down here on my Cartesian coordinates. They've got this 0, 0. This one is 0 plus x and b. This middle is x plus a over 2 and b over 2. This is a plus x and b. And then the bottom one here is a 0. Okay? With the way that this works, we can prove that this is the midpoint of this long line, and it is also the midpoint of this line. Now, you kind of have to know what a midpoint is. So my distance from 0 plus x to a would be to add those together and divide it by 2. So we'd end up with x plus a divided by 2, which is what we have. And my distance from b to 0 is b divided by 2 is b over 2. Same thing here. Okay, so it's midpoint, so I know that this is congruent to this because of the definition of a midpoint. I know that this one is congruent to this one because of the definition of a midpoint. And then I can finish proving this congruent in a number of ways. I could call this vertical angles, and I could work from there. I could find the slope of this line and find the slope of this line, prove that they are parallel, and then say we have some alternate interior angles from the transversals. And of course I could find distance here and distance here running through that distance formula and prove that these lines are congruent. So there's a number of different ways that you can go through this: side, 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 angle, side, angle, angle, side, angle, side, angle. That you could use any one of those to prove that these two triangles are congruent. You're just going to have to do it without the comfort of having those numbers. So as where in the last lesson we were dealing with, we're on the coordinate plane, we have these numbers. This time we're trying to get it done without the numbers. The last thing we have over here, and I have it over to the side because it's basically something that we've already kind of done, is classify triangles. So if we've got a point here, we've got a point here, and we've got a point down here, what you need to do is run the distance formula or run the Pythagorean theorem of a and b here. So a squared plus b squared is equal to c squared. Take the square root of that. You can get that distance and just find the approximate or find the radical form. If two of the three are equal, it's an isosceles triangle. If all three are equal, then it's obviously an equilateral. And if none of them come up the same, then it's a scalene triangle. So we're going back to classifying the triangles by side, but what we are doing is actually calculating distance of where they are on the Cartesian coordinate to do so. Okay, this is an involved lesson. There's a lot of different pieces to it, so I would suggest take a look at the guided practice before you come in, just to make sure you're kind of caught up on what's going on. Make sure you speak up in class, ask questions, or come into tutorials if there's some part of this that did not make sense to you that you don't understand. We'll see you in class.